This is the basics for emmetropization for V551, ocular motility and refraction. Emmetropization refers to the developmental process that matches the eye's optical power to its axial length so that the unaccommodated eye is focused at distance. Emmetropization is different than emmetropia. Emmetropization is the process by which the eye minimizes its refractive error. Emmetropia is a term that refers to the patients with no refractive error. So let's look at newborns and how that happens. In newborns, the eye is relatively hyperopic. The eye has had no visual input, so it doesn't know the appropriate length to be, so it hasn't grown very much during the developmental process inside the womb. Here we have an eye with an image focused behind the retina, like hyperopia. If you look at the distribution below of the refractive error of 3-month-olds, what we'll see is that on average, the average person at that age is about 2 diopters hyperopic. But also, there is a wide range of variability. Some people are -1s, some people are +5s. But the average is around 2 diopters of hyperopia and about 3 diopters range around that spot. What happens for the rest of the person's life? Well, the first thing is what in the eye is changing to minimize refractive error? And the answer to that is it's the axial length. The axial length, as we can see here, is what defines the change in refractive error. Axial length changes determine refractive error during development. But changes in lens power or corneal power do not determine refractive error during development. The key word phrase here being during development during childhood. From birth through childhood, the retina is growing to find the best focal position, and that's what emmetropization is. It's the eye trying to optimize vision to minimize refractive error. The optics, the way I think about it, is the optics, the cornea and the lens set the focal position, and the retina then tries to find that position to optimize vision. Now, obviously, we can cut the cornea with a laser, flatten the cornea, and thereby correct someone's myopia. But that's not development, and that's not what we're talking about here. We're talking about the development of refractive error during childhood and not ways to correct it later on in life through cataract surgery, through refractive surgery, LASIK, etc. So what's happening to refractive error during the first few years of life? The eye grows longer to compensate for the hyperopia, and the variability decreases. As we can see here, looking at different groups of 3-month-olds, 9-month-olds, 1-year-olds, and 3-year-olds, we start to see the actual average refractive error shift from 2 diopters of hyperopia down almost to emmetropization emmetropia by the age of 3. We also start to see that variability decreasing. Remember, at a 3-month period, we had about a 3 diopter range, plus or minus, around that 2 diopters. Over the course of the next 3 years of life, that refractive error is going to decrease in its variability, so there's only a diopter or two different depending on people. And here's just another figure to kind of hit that point home. By the end of the first 6 to 8 years of lives, most children are going to exhibit small amounts of hyperopia over a very, very short range. And that is purely due to changes in axial length over that time. Thank you.